Hello, this is Jack Jackson. Let's take some further looks at transformations, particularly isometries. So suppose we have something like this where we have um, two figures that are congruent. How can we tell what single type of transformation gets this gets to them from the preimage, the blue one, A, B, C in this case, to the image A prime, B prime, C prime. Now here we can see it, and you may be able to know what that is. Well, the first thing is, what if the figure is exactly the same? Well, we know that's the identity transformation. But what if it's something over here? Can you tell what the transformation is here? Well, hopefully you can just kind of tell by looking at it that that's just a translation. But how can we specify exactly what translation, and how can we be 100% sure? The key here is to connect up pre-image to image point with line segments like this. In this case, we notice that all of these line segments are parallel and the same length, and so they are copies of the vectors as long as we put the arrow on the end where the image is, so that the arrow indicates a movement from pre-image to image, and those are three copies of the same vector, and so of course then that is a translation by that vector. All right, let's take a look at another example. Okay, is that a translation? No, doesn't look like it. Perhaps you can see that this might be a reflection, okay? You might be able to just see that. How can we tell for sure it's a reflection and where's the mirror line? Well, again, the key is to connect up those line segments from pre-image to image point. And this time, notice that these line segments are not the same length, but they are still parallel. When that happens, this indicates that we have a reflection, okay? And it turns out that the midpoints of those um, line segments are going to be in a straight line. And when that happens, then we have a reflection. Remember that the mirror line will be a perpendicular bisector of these lines, the original lines that I drew. And so that defines your reflection. You found the mirror line. So remember, if we have a translation, we just have to identify it by what the vector is. If it's a mirror, a reflection, we have to define that by the mirror line. Okay, how about example 3? You probably can guess what it's going to be. How do we get from here to here in a single transformation? Now, we might be able to get there by doing more than one thing. In fact, we can always get there with a series of reflections, but how can we get there in one single transformation? Is it a translation? Is it a reflection? Well, again, the trick is to look at these line segments. Now, this time, these are not parallel, so that indicates it's neither a translation nor a reflection. Well, what are other options? It's not the identity either, so it's either a rotation or a glide reflection. How can we tell the difference? Well, the key here is to look at the midpoints here. And the midpoints, notice, are not in a straight line. That's important. But if you did the perpendicular bisectors of them, notice that they intersect in a common point. Potentially that could be uh, three different intersection points, but in this case it turns out to only be one. If that turns out to only be one intersection point, then that is a rotation, and that intersection point is the center of a rotation. And so you can see we're rotating there. So this angle from A to the center to A prime would be your angle of rotation. Or you could have done it likewise from B to the center to B prime, or C to the center to C prime. All three of those are the same angle. So again, what was the key? The key is when we draw those line segments from pre-image to image point. In this case, we look at the midpoints. They're not in a line, but then we decide to look at the perpendicular bisectors. They are intersecting at one point. That is your center point. And we can see it as a rotation about that center point. And we need to specify the center and the angle if it's a rotation. And here we see that the center point we found, and then the angle, just take any point A, go to the center, and then go to its image point here, and the angle that you're making there is the angle. Well, you can probably guess what this last one is. We have an example here. Well, It's not clear from this one if it could, maybe it's a rotation, possibly, reflection, it's hard to tell. Well, connect up our line segments again. Let me move a point here just to make this a little bit more easily seen. Okay, now we notice that those are not parallel. So we've already eliminated we've eliminated translation, we've eliminated reflection. So now we want to look at their midpoints. And this time those midpoints are all in a straight line. So that means, of course, if we do their perpendicular bisectors, they won't intersect at all. They'll be parallel. So there's no point in really drawing those. But we have those points are in a straight line. And so that means it's our last choice possible. It is actually a glide reflection. Okay, and guess what? That line where the midpoints go through, that is your mirror line. So if we want to find the vector that does this, we want to take this and reflect. I think I did this not the way I really meant to do it. Let's see if I can fix this. So what we want to do here now is just reflect this final image back over the line, and that gives us our intermediate image. And then the vector is just connecting a pre-image point to one of these intermediate image points, the corresponding one. So there's your vector. Now if you stake this original one, slide it along that vector to here, then you're going to reflect around that parallel line here to get that. And remember that line was where the three midpoints all lied in a line from these lines segments connecting up pre-image to image point. So we have worked out each of these examples. So here again are those kind of pictures that we just saw. And so here's a summary of what we came up with. If all the image points are the same as the pre-images, then we have the identity transformation. Now remember what we're doing here. We're just giving the two figures like two triangles, two congruent triangles. We're trying to figure out which isometry, which single isometry maps one to the other. There are only 5 types: identity transformation, translation, reflection, rotation, and glide reflection. If all the image points are the same as the pre-images, it's got to be the identity. Super easy to see that one. Line segments connecting pre-image points to image points then are the keys for deciding which of the rest happen. If they're parallel in the same length, then it's a translation. Each of these line segments is a copy of the same vector if you just put the arrow on the correct end to go from pre-image to image. Resulting isometry is a translation by this vector. If the line segments connecting pre-image to image points are parallel but not necessarily the same length, but the midpoints of these segments are collinear, call this line M. Okay, then the resulting isometry is a reflection with the mirror line being M, that line that connects the midpoints. If the line segments connecting pre-image to image points are not parallel and the midpoints are not collinear, but the perpendicular bisectors of these line segments will then meet at a common point X, the resulting isometry is a rotation about the point X. Take any pre-image point A and its image point A prime, then the amount of rotation is the measure of the angle from A to X to A prime, measure that angle X. And finally, for a glide reflection, the line segments connecting pre-image to image points are not parallel, but their midpoints are collinear. Call this line M, and the resulting isometry is a glide reflection. The mirror line is M. Reflect the image over that line M to find the intermediate image. Let A be the pre-image of A prime, right? And let A double prime be the image of A prime via this reflection. The vector for the glide reflection, of course, then is from A to A prime. Now, if more than one of these things happen at the same time, then there may be more than one transformation that will get you from one figure to the other. And certainly that can happen if the figure is too simple, like if there is just a line segment, you might be able to get there perhaps by, say, both a reflection and a rotation, for example. Or if it's a single point, there's a whole bunch of different ways that you might be able to get there. Or if it's maybe it has a high degree of symmetry, there are certain cases where there might be more than one way of getting there. So, but in general, say if it's a scaling triangle, exactly one of these 5 cases will be what happens. So that's how you can tell if one is a what which one it is. So here's an example. So see if you could try these, and maybe take a picture of this and then see if you can figure it out. So what transformation is going on here? You might be able to just look at it and tell, but you can use the method above to be for sure. Now, how about this one? You know which one is going on there? How about that one or that one? Okay.